Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. I request everyone to try this question in the comment box. Don't worry, after some to hear the right answer with explanation. I believe you have tried, so let's start. Now question is, what is the correct order regarding the rate of nucleophilic substitution with ethanolic silver nitrate? So how they react this three iodide derivative with ethanolic silver nitrate and what is the rate of their reaction in case of nucleophilic substitution. Actually, technically, if I said SN1 reaction. Now, what is the original reaction? Rx plus silver nitrate produces R plus nitrate plus silver X. Now, generally for this reaction, this X could be Cl, Br or I means as a halogen, but in this example it is actually alkyl iodide. So you can see here iodide derivative they are given, and it reacts us with silver plus. Silver nitrate is an ionic compound, it produces silver ion. So what happens here, this iodine coordinates with this silver atom with its lone pair. Consequently, this Ri bond breaks down, produces a carbocation. Obviously, and this silver halide, I mean silver iodide, chloride or bromide, they are insoluble. So later on this carbocation reacts with this ethanol to produce this ether molecule. So this is the overall reaction. Now if you look at the rate of this reaction depends on the stability of carbocation. So you can see the rate of the reaction versus stabilization of carbocation. So let's look at the carbocation here. So here you can see if these leave, so it produces this cation. If this leaves, it produces this cation. By the way, this is actually cyclopentadienyl cation, and this is very interesting. It is actually, student, anti-aromatic. By the way, I have already discussed a dedicated lecture on this. You may visit for further learning. And this is actually cyclopentyl cation. So there are three carbocation is produced. Now the question, which one is maximum stable, which one is not? Now if you look at carbocation number 1, it is, student, aromatic according to Huckel rule. What Huckel rule says? So Huckel rule says that compound must be cyclic. Okay, so it is cyclic. Compound must be planar. Yes, it is planar. It must be conjugated and every atom has a p orbital. Look at this, oxygen has two lone pair. One of the lone pair is in p orbital. And by the way, this is positive charge. Positive charge means a vacant p orbital. And fourth rule is actually 4n plus 2 number of pi electron for aromatic system. Now here 2 pi electron, 4, here 2 pi electron, so total 6 pi electron, which is actually a Huckel number. So these option A, you can say it is aromatic, means you can say it is stable. Now the next option, if you look at the next option here, cyclopentadienyl cation, it is, student, anti-aromatic and it is unstable. Okay, now why? Look at 2 pi electron, total 4 pi electron. It is cyclic, planar, conjugated. Every atom has p orbital. So because of this 4 and pi electron, it is anti-aromatic, unstable. And what about this? This compound is non-aromatic. So it actually has a moderate stabilization. Means you can see here 4 alpha hydrogens are there. So you can say 4 hyperconjugation, point number 1, and since it's a secondary carbocation, so 2 plus IFX. So these, but this stabilization is significantly lesser compared to this aromatic stability, because aromatic molecule means it's delocalized, delocalized means stabilized. So if I say the stability order, obviously here option 1 is greater than option 3, next is option 2, because option 2 is maximum unstable because of its anti-aromatic nature. So if it is unstable, it will be produced least because the corresponding energy of activation will be highest. So this is explained by Arrhenius equation. Let's look at here. So this is your reactant, you can say this is Ri. This is your carbocation, just we have discussed, and this is your product, so you can say it is ether. Now one case maybe intermediate energy here, another case here, another case here. So you may consider this is option 1 aromatic, this is option 3 non-aromatic, and this is option 2 maximum unstable, means anti-aromatic. So you can expect that this is the energy of activation for this aromatic one, the option number 1. Now one thing, there is actually a relationship, means K is equal to A into e to the power minus EA by RT. So what does this equation means? This is Arrhenius equation. It says the rate constant is inversely means actually you can say this is e to the power sign. So you can say one thing, that this rate constant increases if EA decreases. So lesser the energy of activation, higher is the rate constant. So this is, you can say, energy of activation. By definition, it is the minimum amount of energy required to carry out a chemical reaction. So since the aromatic one, means option A, has maximum stability, so its energy is minimum. So energy of activation is minimum, so rate is maximum here. Second, obviously for option 3, non-aromatic, and the lowest, means smallest, or the lowest rate will be observed for the anti-aromatic option 2. So what is the right answer? You can expect that option 1 greater than option 3 greater than 2. So this is the answer. So now if this question appears in your exam, how can you get the right answer less than 30 seconds? First, silver nitrate. Silver likes halogen, so it will take and produce silver iodide, and it will result a carbocation. So remove it. Look at 3 carbocations. Which one? What is the stability order actually? This 1 greater than 3 greater than 2. And energy of an intermediate directly indicates the activation energy. By the way, there is little thing that okay, this is actually not the energy of activation. Energy of activation looks like this. This is the intermediate, again another like this. But I don't want to go that much complication, so you may consider actually this energy of activation resembles to the energy of intermediate. Why? Because energetically both are closer. Since its energy lesser, option A, so its energy of activation will also be lesser, so consequently rate of reaction is faster. So this is the actual thing. Now I believe you have understood. This is a very interesting problem, so this is the overall discussion. But before ending this video, please student, please do not get confused with the logo of my channel, swastika. It is swastika, it's a holy sacred sign in Hinduism, but it is not hooked cross, which is the sign of Hitler. I do not support any kind of brutality. This is a holy sacred sign. So please do not get confused by this misunderstanding and wrong information. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.